All right, and we're recording. So this is the fourth TCR Community Collaboration Coalition call. So what we're going to do first is introductions for people that are new to the call. I think this call format is a really great opportunity for people around the world to come together who are working on the same thing and talk about it. So it's really awesome to know who else is on the call, what they're working on. So if anyone is new to the call and hasn't introduced themselves, and if you want to talk about what brought you to the call today and what you're working on, that would be awesome. And if you could just put a me in the chat, I'll go down the list. That way it's not awkward, who's going to introduce themselves and talking over each other. So if anyone wants to introduce themselves, just shout out in the chat and I will call you up. And we have one, and it's Nick. And Nick is in Boston here with a lot of us level K people. So yeah, introduce yourself, Nick.
Hey everyone, my name is Nick Emmett. I lead blockchain development at John Hancock and Manulife, which is a large insurance company in the US and Canada and Asia and stuff. And we're exploring decentralized insurance on public blockchain on Ethereum, and I'm really interested in curation markets and TCR, so that's what kind of brings me here. And I think there's a lot of useful applications and how it can be used in governance and kind of creating fractional reserves for insurance and kind of handling dispute resolution and oracles and outcome verification. So yeah, I decided to join because I'm excited to hear about conviction voting a bit more too.
All right, Nick, you're the only one. Usually have more people. But thanks for joining, Nick.
Yeah,
happy to have you. Oh, and then James. Introduce yourself.
Got to unmute myself. I'm James Glasscock. I'm based in Los Angeles. Have a company called Elephos Ventures. We're really interested in and focused on the future of work. And kind of what brought me into the rabbit hole is curiosity around TCRs, bonding curves, curation markets. Previously, I co-founded a company called DNA Fund, participated in a lot of the ICO stuff last year. And prior to that, spent 19 years in the media business at companies like Warner Brothers, Playboy, Machinima, and Turner Broadcasting. Nice to meet you all and hope to see some of you in Berlin next week.
Yeah, thanks. Thanks for joining. Anyone else? Emmett. Yeah, so today we're going to talk about different voting mechanisms other than PLCR voting, and Ames is talking about anonymous voting. Jeff, if his internet connection cooperates, we'll be talking about conviction voting. So hopefully that will go okay. Yeah, and also, the video format I think is kind of new. Well, not kind of new, but more and more people are doing it. There's a curations one, markets one, and I think a big advantage over reading a blog post or watching a YouTube video presentation is that here we get to listen to someone talk about what they're working on and ask questions and engage with them. And I don't know, ideate together, talk about it. So I definitely encourage people, if you have a question during a presentation, just ask. That's fine. And I encourage you can just ask with audio on video. You don't need to go to the chat. You can, but encourage kind of speaking and make this more of a collaborative conversational group. Yeah. So I'm going to hand it over to Ainsley to talk about anonymous voting.
Yeah. Cool. Thanks, Emily. Good to see you all here again. So I work at Enigma, and we've been working for almost a year now, kind of playing around with this idea of what we call secret voting, which sorry, is that me clicking or is that? Okay, I think it's okay. Which enables people to vote without having the vote be tied to their particular identity and revealed afterwards. This came up for us because of an interest in basically private data and enabling people to vote with privacy. But it also, as we continued to play around with this and experiment with it for TCRs, we realized that there might be additional benefits for UX because you don't have to have the second reveal step, which people have sometimes encountered a lot of challenges with. So that's kind of why we bring it up in the context specifically of PLCR, and as a potential replacement to it. It's also kind of how we started talking to Level K a couple months ago, kind of thinking as they were talking about building a modular TCR. We got really interested in that possibility because we thought this is exactly like kind of a modular thing that could be swapped out if somebody wanted to use a different mechanism from PLCR. So I thought what I could do today is kind of give you a brief overview of what Enigma does if you're not familiar, a sense of what our network architecture looks like and how it works. And then I pass it over to my colleague Audie, who can show a demo of a private voting, like how it works, and just kind of walk through it. And you can, of course, as Emily said, feel free to interrupt us and ask questions at any time. And I also note that we've been working with Bingen and Luke for the past few months to see how we can integrate this with Aragon's dev chain environment. We haven't got there quite yet, but we've been working on it a lot. And I know that Luke and Bingen, who it looks like isn't here, but I'm not surprised by that. I'm sure he's busy with stuff for Aragon, have been doing a lot of thinking about voting and the different voting mechanisms. So I invite them both to especially interrupt with their own feedback and thoughts as we move forward. Cool. And I'm going to now share my screen. Somehow, hold on a second. Speaker view. Guys, I don't use Zoom that much. How do I?
When I move my mouse over Zoom, I see a share screen button in the bottom of the screen, right in the middle bottom. It's a green button.
Share. Got it. Sorry.
Yeah.
Okay. Thank you. It's too obvious. That's how I missed it. Okay. Cool. Okay. All right. So Enigma is basically a network for secure computation, which means that we can run computations over private data that's never exposed to the nodes that are performing the computations. Right now, we function in a way that complements Ethereum, so that you basically submit your contract to Ethereum with the private data being passed along to our network, where the computation is run and the results are returned back to the smart contract. What that essentially looks like is the developer basically deploys their contract to the Enigma contract, which runs on Ethereum. And then the user encrypts the data on the client side and then submits the data via task to the Enigma contract, as well as to our network of workers that are basically Enigma nodes. A worker is selected randomly, performs that computation, and then returns the result to the Enigma contract, or to basically call back on Ethereum, and as well possibly to the user. So at a very high level, that's kind of how it works. The current release we have will use something called a trusted execution environment, and specifically in this case, it's Intel SGX. So also open to your thoughts and questions around that later on, or now, or whatever. But that's kind of how it works in our first iteration. And as I mentioned earlier, the motivation for us to kind of get into private voting was this idea that, voting systems generally that are robust, you can't reveal how you voted in order to prevent things like bribery, or what you've probably heard of referred to as vote memeing, where if the vote's public, you can kind of just vote with the majority in order to not maybe do any background research or thought on your own process. So keeping votes secret until they are tallied is something that the sort of ecosystem clearly benefits, and that's kind of why PLCR was implemented. And so, unfortunately, though, PLCR does have to reveal the votes later on once the vote's concluded, which means that certain attacks that have been written about, and we've actually seen presentations on, can still be performed, like vote bribing via smart contract. And then, as I mentioned, one of the main differences that kind of emerged as we started working with this was that there is no reveal step, which can hopefully lead to higher vote turnout. And there's obviously a lot of factors that affect vote turnout, but this is one of our working theories. Very curious to hear people's thoughts on that as well. So without further ado, so that we're all on the same page, we'd love to show you the demo of it working. Audie, if you want to go ahead and take over from here, I will stop the share.
Awesome.
Also,
sounds good.
Yeah, cool.
Oh no, go for it. Sorry.
Oh no, just after Audie's demo, then we'll open up for a quick question pause too, if you guys want. That's makes it more comfortable instead of feeling like you're interrupting me. I know it can be hard to do on a video. Go ahead, Audie.
Yeah. All right. Let me share my screen. Okay, can you guys see this all right? Okay, great.
Yeah, looks good.
All right. Okay. Awesome. Yeah, thanks again, Ainsley. Sorry, something is blocking my screen. Let me see like this. Okay. Cool. Hey everyone, as Ainsley mentioned, we have a demo of a voting application that we've built with the Enigma protocol. The app maintains voter privacy by allowing the results of a poll to be computed without ever leaking a user's particular vote itself. The very first thing to note up top is this dashboard right here. We have a menu with the test network accounts at your disposal, so we'll keep things initialized to the very first account for now. The next two terms are terms that are probably very familiar to many or most of you when it comes to decentralized voting. The first is current token balance. This refers to the number of mintable tokens that the user has purchased. We have a simple exchange rate for the purpose of this app of 10 tokens for 1 Ether. Number of stake tokens refers to a portion of these voting tokens that the user is willing to commit to the voting contract. We've implemented a token-weighted voting system here. And as such, at any given point in time, a user is able to vote with a maximum weight that is equal to the stake token amount. So we'll start things off with the very first user purchasing 10 voting tokens. And we will go ahead and stake all 5 of those tokens to the contract. You can see those numbers reflected here up top in the user dashboard. And then the user will go ahead and create the very first poll in the system. There are a few bits of information that are required for this. The first is quorum percentage. Quorum percentage mandates that in order for a poll to successfully pass, the number of yes votes divided by the total number of votes needs to exceed this ratio. For description, we'll ask a question such as, is privacy important for voting? Perfect for this demonstration. And for voting period, we'll go ahead and start things off with a 60-second timer that this poll will remain active. Great. So this poll has now been created. This very first user will go ahead and vote with a weight of 5, saying, yes, privacy is important for voting. This vote has now been cast, but more importantly, take note of how this vote has been saved. It's been saved in an encrypted bytes representation, which you can see here in the console log that I've highlighted below. We do not store the vote itself. So we don't store 1 or 0, yes or no. To reiterate, we store only the encrypted form of the vote, thereby not exposing the vote to any third party. We'll go ahead and, as the second user now, come in and purchase 5 voting tokens, stake all 5 to the contract, and this time with a weight of 3, say no. And once again, note how this vote has been stored in an encrypted bytes representation instead of the vote itself. Once this timer ends up here that you can see, the poll will automatically end, triggering a very important function in our system called the callable function. This function runs the secret computation inside secure SGX enclaves on the Enigma network, which then decrypts the votes, tallies the results, and subsequently calls the callable function. Once this is triggered, the callable function, the callback function rather, sorry, the callback function is in charge of altering the contract state and actually updating the poll status in the end. So for those of you keeping count, we had effectively 5 yes votes to start with and effectively 3 no votes, which passes the simple majority. Thus, as you would expect, the poll passed. And this is handled with a front-end event watcher that waits for the event that's emitted from the callback function that I was just talking about. And this is indicated by this green check mark right here, signifying that the poll has, in fact, passed. Yeah, that pretty much wraps it up for this, this private voting demonstration with Enigma. But as Ainsley mentioned, feel free to ask any questions that you all may have.
So it keeps it a secret what direction you voted in. Is it also secret whether or not I voted? Can people tell whether I voted?
For this implementation, the fact whether someone voted or not is public, but yeah, as you pointed out, the direction, whether you voted yes or no, is encrypted.
Cool.
I guess one way to think you could include like a null field so that people can vote, but it doesn't count, would be one way to mitigate that. Otherwise, it's something a little bit, it's like more transactional privacy, which is kind of a different functionality than what we can provide right now.
Right. So that's not really like something you're thinking about. You're mostly protecting like, what people decided and not really thinking about obfuscating whether or not they voted.
Yeah, I think that participation wise, like probably the most straightforward way would be to make a null vote option.
Yeah. Cool. Yeah, and maybe like, I don't know, from the client, like that could like, if someone didn't vote in time or something, you can just like put a null in there for them or something. Yeah, cool.
Yeah, that's interesting. Like if it's something where you want to make sure you're not like receiving like some type of penalization for not voting, or like, don't want your reputation as a non-voter to, I guess that's interesting in terms of the application. Like it may be something that's valuable for people to kind of have that visibility to see like what addresses are not participating regularly.
Yeah.
Where like a null vote could give you the participation, like you could be participating but doing a null vote. I guess it's an open question. I would like to see an application where that's a concern for them and understand like what the parameters are too.
Can you guys talk a little bit about the network aspect of Enigma? So like the security assumptions of using this as like a static secure enclave versus passing it to the network, and kind of how nodes participate and join and leave the network?
Indeed, I can. In fact, I have a slide prepared just for this question. 1 second, let me pull it up. Regarding nodes joining and leaving the network, that might be a little bit in the weeds for right now, but I can give like some basic overview of the security assumptions. You guys can see my screen now. So basically the network of nodes are nodes that are running something called Intel SGX, which is, like Luke mentioned, a hardware enclave solution. And there's basically two assumptions at play with this type of solution. One is at the computational integrity, and the other is at computation privacy. So computation integrity basically means that we know that when we submit our votes and they're tallied in the enclave, that tally has been done correctly, and the tally itself is returning a correct result. We can trust the results of the tally. Computational privacy is that nobody saw those tallies in an unencrypted form. That is, that the worker performing the computation doesn't actually see the data that is computing over inside of the enclave aspect of the system. The assumptions for computational integrity are basically, one, the SGX remote attestation process, and two, that there's worker consensus among nodes. So in our current development release, which we're calling like minimum viable testnet, we only have one node, so we don't have this. But moving forward, and as we move into production, we will have more than one worker node that is actually achieving consensus about the results of the computations. And so that would be something where if the computation that's being returned from one worker differs from those being returned by the majority of the other workers, you have some sort of other constraints on whether the result, like whether you can trust the result that's coming back or not. Regarding computational privacy, we are using side channel resistant encryption libraries. That is something that would probably have to be more deeply hashed out with our privacy engineers. And we are also, because we have a network of nodes running it, it's a randomly selected worker performs the computation on that network. So there's no way to guarantee that you will personally own like the node that's selected to run the computation that you're interested in sort of extracting the data from, if you are going to perform a side channel attack or attempt to do that. And all I can say about that is it's also kind of an active area of research. As for how worker nodes join the network, they do go through an attestation process, both with Intel, and we also have another parallel process within us. So there's kind of two different certification processes. And I don't have slides on the Intel attestation process right now, but I'm happy to also kind of go over that with anyone that's more interested one-on-one too. But I would have to kind of like get ready for that convo, unless there's specific questions that I haven't answered about this either.
Yeah, the only question that I was going to get at was just about the security assumptions, not in the testnet because you're just running one node, but in the later versions about like availability and like liveness of the network. So like for in the context of like private voting, for example, and specifically in the context of Aragon, if somebody were to run an organization that has a permission for like a specific vote instance to like protect certain funds, and then the Enigma network is no longer available, or the specific instance where the encrypted key tied to that private vote is no longer available, then all of the funds that are protected specifically by that vote would be no longer accessible, presumably. So just sort of curious about that specific any specific guarantees that are planned around availability.
I can jump in. This is John from Enigma. So in terms of key exchange, so with the next release, it's a network, right? And then all nodes in the network are communicating with each other using lit-P2P. And that communication is to update the state and exchange key information. So as long as the entire network is not down, then there should be no issue in getting the right keys to decrypt the states and also decrypt the inputs that are coming into the network. And that becomes like a numbers game, right? Where our initial approximations seem like we should be expecting around 50 nodes or 50 workers when we launch. And so I'm guessing like there will be, with 50 nodes, there should be some good uptime. In terms of, so that's just like, you know, exchanging state keys, etc. And then for each epoch, which is like a series of let's say computations or like just a time frame, a group of workers are selected. If all the workers are down at that point, then yes, it's an issue. But that's something that we're trying to enforce with slashing and economic penalties that are tied to the staking.
I don't know if this question is like it has been answered, or because I don't understand the ins and outs of like how it's working behind the scenes, but you know, people encrypt their votes and then it eventually needs to get decrypted in order to be counted. I'm not sure how it gets encrypted and decrypted and who has the power to decrypt it, and if someone holds that key that can do that.
Yeah, so on basically the way it works is the user, right, the DApp user would have their own private key. And then when they end up trying to send a task to the network, they will receive the worker that's going to be working on the task, their public key. And so there's a shared key that they can create using my private key and the worker's public key. And so then when I send the task to the network, only that worker with that matching private key for the public key that was sent can decrypt my information. And then similarly on the way back can re-encrypt the data with my public key and the worker's private key, such that only I can receive the computation results and make sense of it again. So that's how that kind of encryption key exchange works between user to worker. And
so is there an inherent trust in the worker that they won't disclose that information?
Sorry.
There's what information specifically do you mean? The data or their public, like
the data, that their vote?
Yeah, so that's kind of like where the hardware comes into play that Luke was talking about. So the worker doesn't even have access, if we trust this hardware component, to the data inside of its enclave.
All right, yeah, that answers my question. And I'm going to try, I guess, to time box this maybe 5 to 10 more minutes and then move on to conviction voting.
Cool.
I have a question. How can I ensure that my vote actually got counted with everyone else's vote? Like, is there a way to do that on chain, or do I have to like trust something in the network in order to like verify that mine actually got counted?
That's a good question. I mean, when you send your task to, like, you're sending your encrypted vote, you'll receive in some sense like a receipt that your task has finished. And so there's kind of two levels of receipts. There's one on like an Ethereum chain of like this task record has been created, and there's a second one that this has been sent to the Enigma to the Enigma network, and the computation has in fact been run. So you'll receive those. I guess as for when the votes are itself tallied to make sure that your vote officially made it in there, that's a good question. It's not super clear right now that can be done, but there is like a guarantee that, you know, you receive the receipt from both Ethereum and from the Enigma network that your task successfully made it through.
You also don't necessarily want to provide that receipt. Sorry, from a voting perspective, you also don't necessarily want to provide that receipt if you're using private voting to avoid bribery. As soon as you give somebody a receipt that shows that the vote was processed correctly, like specifically including the vote information, then you've lost the privacy guarantee, because somebody can then use that to prove exactly how they voted.
And Luke brings up a pretty good point too, which has come up for us too, which is because TCR specifically reward your vote with tokens, it's obvious at the end of a vote that if you suddenly have 100 tokens you didn't have before or whatever, that you voted in the direction of the winning outcome. And some of the ways that we've talked about with Luke and with other people about mitigating that is possibly batching those rewards across multiple polls to provide some level of obfuscation. It's still an active, I would say, question. I think some of the like factors that play into that is like, how frequent are these polls? Like, does that make sense? Is that something that would affect like people's liquidity too much and they wouldn't want to wait for those polls to conclude? So it's definitely still kind of open question. And then just one more note about guaranteeing that your vote is counted. Let me just wrap this up real quick, John, and then is that you can see the computation that's going to be run. Like that's public, that's not secret. So you can confirm what the function is that you're submitting your data to. And so if that function says they count everybody's vote but exclude Ainsley's, that's one way to know that. But you can see the computation that's going to be performed that function. So that should also provide some guarantee that, like, if I get my receipt and I see the computation, there's not a lot of room for a secondary computation to come into play or for like, aside from blocking my vote from being submitted in the first place, because it will be run in the way that it says it will be. Okay, sorry. Go ahead, John.
No, I'm sorry. Two things. Like you can't do like an on-chain confirmation on Ethereum, but then there is a network that Enigma runs on, and then you'd be able to like make sure, as everyone again, as you mentioned, that it's been received and it's been worked on. The second thing around TCR and how to potentially obfuscate where your rewards go. One thing you can do is you can create or indicate a new address where you want the payout to go to. And if that address is a brand new address, then there's no way, I guess you can argue that if you're getting 100 tokens back, like someone could potentially track, but it would be very, very easy to gaming. So like no one would know that it's necessarily coming from that address. So what I'm trying to say is like you can add inputs where you are changing the receipt address to an extent, but yeah, to be more researched.
Yeah, so that's kind of like adding in like a level of like coin mixing sort of at the end of the payout. It's like John mentioned, that's one possibility, but it's a little bit more complexity, so we haven't pushed too far into that yet. One question that we kind of had for everyone is that we've heard ideas of like vote delegation come up in the past, where maybe you have like the reason for wanting to trust someone with more like like maybe you don't want to be participating in every single vote, but you have someone you'd like to delegate it to. And I'm just curious if people have any thoughts around like delegated votes and vote secrecy, whether that's something that like just doesn't work, or if there are urgent use cases for that. If anybody's got any thoughts there.
first thought, actually coming from Giveth, and we have a delegated or liquid pledging, which is kind of liquid democracy, but with funding rather than votes. And my thought on that is, if I were giving my vote to a delegate, I would want to know what they were voting, so that I knew that they were representing my interests. I don't know if that goes against the ethos of private voting or not, but that would be something that's a good question for me.
Yeah, that's actually a really good question. That's kind of what I was thinking about, which is like you need to be able to verify that like your selected delegate is not like voting against the way that you want them to act. So it's almost like maybe the level of like where the privacy comes in is about which delegate I select. So maybe a delegate themselves doesn't know who is supporting them or where that support's coming from, but I, as the person who selected the delegator, can audit the delegate's votes. So for example, the delegate votes publicly or with some type of commit reveal process, but the people that are endowing the delegator with their votes can pick which delegator they select in a secret manner. That would be like my instinctual option, but I haven't thought too much about it.
Awesome. We're like running towards time, so I don't know if there's anything Enigma wanted to say to kind of wrap up the conversation on anonymous voting before we move to conviction voting.
No, but thanks for your questions, guys. Would be happy to talk further about this, or if anybody wants to try testing it out or talk about some type of future implementation that might be useful for their TCRs, I'm more than happy to chat with you.
Yeah, thanks so much. I guess like the two talks, it kind of makes it kind of a lightning round conversation, but still productive. So thanks.
Yeah.
Thanks.
And we'll hand it over to Jeff.
All right. First things first, can everybody hear me clearly?
You seem to be coming in clearly now.
Okay, cool. I ran Zoom on my phone, so this seems to be working better for me. So if I do cut out at all, please forgive my internet and my groggy brain. It's 2 a.m. in Bangkok, so I may not be as quick as I am on normal hours, but I will try to field any questions, and if there are any I can't answer right now, I will definitely write them down and get back to you another time. So coming into this from Giveth, and I'm sure many of you know Giveth, we're planning the future of giving through blockchain, and to enable effective donations to charitable causes, we need to make effective decisions on how that funding is allocated. So one of the first projects at Giveth was liquid pledging, which allows people to not just donate money to a cause, but allocate that donation to a delegate in the system. So presuming that you know someone who is in this cause and they know more about where those funds could be useful than you allocate your pledge to them. So that's kind of the first product out of Giveth, although we're doing a lot more to DAOify these projects and communities and create communities around causes. So that's kind of where the curation markets idea comes in, and that's where I got involved. We're also working quite closely with an R&D firm called Block Science, which is run by Michael Zargum. And you might hear his name a few times through my explanation, just because all of these are his ideas. I have been working with him to kind of translate his ideas and step them down from like academic and complexity theory language, which is a little bit difficult to parse, into something more engineering and crypto appropriate, and applying these ideas to the systems that we have in use today. So we definitely are coming at it from a high-level systems view, always trying to design as nature with biomimetic properties wherever possible. So conviction voting is kind of a TCR, but rather than having a time-based vote, it would be continuous preference broadcasting. So if you were part of this TCR curation list, rather than a vote happening over a 72-hour period, you would always be voting with the stake that you have in the system allocated to whatever preference bucket you prefer with weights. So you might say, you know, option 1 has 50% of your weight, option 2 has 25, option 3 has 0, and option 4 has the remaining 25% of your weight. So to kind of look at this from an example in nature, I don't know how many people are familiar with Paul Stamets' work with mycelium. He studies mushrooms, and he's done a lot of work looking at mycelial networks in forests, and they've found that actually these mycelial networks communicate or allow trees to communicate and pass nutrients from one to another. So there's kind of this continuous preference being broadcast from each tree to other trees, and they've found that trees you know, prefer giving nutrients to their own species and even their own offspring over other trees. So, you know, trees don't come together on a Wednesday and say which trees should we vote out. They are continuously broadcasting their preference at all times. So it's kind of trying to emulate that a little bit more. And one quick note, conviction voting is still in an idea phase, so we don't have any concrete modeling, simulations, or code, but that stuff will be coming over the next few months. So if you guys have any questions or critiques, I'm more than happy to hear them. So TCRs are very cool. They allow us to order information to make better decentralized decisions. But as I mentioned, this kind of time lock opens up a few attack vectors. So in TCRs, we have a problem with vote buying, where if the vote is happening on Wednesday, well, on Tuesday, I can either tell a bunch of token holders to vote my way and I'll pay them, or I can just buy a bunch of tokens and influence the vote. So you can, and I believe this is called vote buying as an attack vector. So when you remove the time-based vote, you shift it from vote buying to vote renting. So if someone wants to influence the vote, they still can. However, they need to control the votes for as long as they want, or they need to pay the token holders for as long as they want to control the vote. So the cost to vote rent tends to infinity. As long as you want to control the system, you have to be paying to do it. You can't just buy them on Tuesday and the vote goes on Wednesday and you can stop paying people on Thursday. You have to be continually paying people to vote and control the system. So you're removing that attack vector, which is one great thing about it. Let's see here. So also coming at it from
Can I ask a quick question? Sorry.
Yes, sure.
I can also wait if you'd rather.
No, go ahead.
Okay, so my question is this something that would be ideal for like continuous things rather than things where a decision needs to be executed and then acted upon, like a vote that is ongoing? And do you have like kind of like a, I guess, like a categorical example maybe for like an ideal vote question that this would be good for?
For sure. So there would definitely be a few different cases, and I don't think conviction voting would replace all TCRs, because there are times that you need, you know, a decision made and it's a final decision. So the area that we're looking to implement this is kind of like a recommendation engine. So I wrote an article about curation markets back in November. I know a few people have read it. I can post a link to it in this chat when I am back on my computer. But the analogy the example that I used was cleaning up beaches in Thailand. So we have a list of beaches in Thailand that need cleaning, and we have a community of people who have donated and want to see these beaches cleaned. So now there needs to be an ordering of these proposals, and all participants in the curation of the list can say, okay, well, I am going to put 100% of my weight behind this beach, beach A. Someone else says, no, I think beach B is more important. And once you aggregate all those preferences, you kind of have an ordered ranking of beaches that should be cleaned. Now, there has to be some decision period where a proposal passes. So the continuous voting, yes, it is continuous because you're always broadcasting a preference. However, some of those preferences may pass at a certain time and leave the ranking, and then preferences have to be reallocated after that. So there is some time element to it. And again, depending on the context that you're using it in, there may be some different applications of how that, we're using it as a recommendation engine, more or less, at this point. Does that answer your question?
Yeah, it does. It makes a lot of sense. Thank you.
Cool.
Can I ask a question?
Yeah.
Have you guys, I know like conviction voting is kind of a general concept. Have you thought about it in the context of a TCR and how that would work with the way things are set up right now? So someone stakes money to enter something into the TCR and there's a challenge period and then people get rewarded based on how people vote. So in this case, I don't know if you've thought about how a person stakes an item to the registry, and if people are staking on it, say, I like this, if it gets below a certain threshold, is it officially off, and does their stake get divvied up somehow? Have you guys thought about it in that context?
Right. So I don't think it would be a binary list in that you would be on or off. It would be kind of a continuous list where things that were of low preference to everybody on the list would just be far, far down the list. There is no cutoff, at least in the first ideas we've had about this. Sorry, can you repeat the second half of your question again?
That almost answers the second half, because I think I was talking about divvying rewards for voting someone off the list, but also, are people rewarded for curating this list
Yes.
as well?
That's what I was gonna speak to. This was a concern of mine in the beginning as well, because with the TCR, you are able to reward people who voted with the correct, with the majority side. There is no reward to conviction voting other than having an ability to affect the decisions within that community. So there is no monetary reward in conviction voting at this point in time anyway. Intrinsic rewards, exactly, Luke. Yeah, you have governance ability to direct community in the direction you think it needs to go.
Unrelated question. I'm like excited about conviction voting. I'm curious from an implementation standpoint, the feasibility. Have you guys looked into that in terms of like if you've got continuous balanced updates that are affecting like the weights of all of these things? If you need to act on the actual like balance at any given standpoint or point in time, is that something that can be done securely on chain, or is it something that like kind of like Carbon Vote is easy to tabulate off chain, but more difficult to efficiently tabulate on chain?
Right. So actually, maybe I'll explain sort of. I guess you're talking about like the decay function, the forgetfulness function.
Yeah, so I haven't gotten too detailed, like too in the weeds in terms of like the exact implementation details. But I remember when I first read kind of the paper that Zargam had sent me, and maybe it's changed, there being updates related, like basically continuous updates to the balances that I wasn't sure, and I'm obviously not like a Solidity engineer by any means, but I was curious how that would actually like efficiently be done on chain.
For sure.
Or if it's necessary, right? Like if it's a recommendations engine, maybe it's just not necessarily necessary to have consensus on the exact balance at any given time.
Right. So maybe I'll introduce an analogy just to make it a bit easier for everyone to picture. So the way Zargam explained it to me, which kind of keeps with that biomimetic and fluid dynamics. So each person who is curating the list is a faucet, and your preference is pouring out of that faucet, and every preference on that list is a bucket. So those buckets are filling up with the preference of everyone who is helping to curate that list. but each bucket has a small hole in the bottom, which is leaking preference out. So this is your forgetfulness factor. So this serves a couple of purposes. One, you can't move all your tokens from one preference to another immediately. So say, it's Tuesday night and the vote's happening Wednesday, and I just switch from no to yes. This causes some volatility and instability in the voting mechanism. So when we treat things as fluids with this decay, so your preference is only accumulating in this bucket at a steady rate, and it's also disappearing from these buckets at a steady rate, not necessarily the same rate, but there is some accumulation rate and there is some forgetfulness rate that eliminates the need for token locks. So token locks are kind of our way to prevent people from moving tokens here to there really quick and changing like last minute vote volatility. The problem with arbitrary token locks is they could potentially cause systemic liquidity problems somewhere down the line. We don't really know, but for an example, if everyone couldn't spend 40% of their money on a Wednesday, what effect does that have on the overall economy? It could snowball into something bigger down the line, which is kind of what they call like a second order effect on the system, and they can be very non-intuitive, but they can cause weird volatility, weird effects in the system. So ideally, we want to try to avoid token locks, and instead, and I mean this is within conviction voting, of course. Instead, replacing them with this fluid dynamic model of your preference is pouring out of a faucet, and it's also decaying, or pouring out of the bottom of the bucket at some rate. So if you move your preference from bucket A to bucket B, it doesn't just disappear from A and suddenly appear in B. It slowly drains from A as it slowly pours into B. So you kind of have this this accumulation factor and a decay factor. So this is an issue with on-chain computation, trying to fit a continuous function into discrete time blocks. However, I believe because it is just a linear accumulation rate and a linear decay rate, it can happen off-chain. So, I mean, I've asked Zargam about this question, and I don't know enough the technical implementation details to probably give a satisfactory answer. But as far as I understand, you don't have to compute each step of that on chain. You can just have an off-chain function measuring, the accumulation rate, the decay rate, and at the point where a system's state change would occur, where preference B overcomes preference A, for example, because your preference is draining out of A and allocating in B, as soon as those switch, the off-chain function can update the state in the block. So it wouldn't have to be an update every discrete block. It would just be once a state change is called, and you would know that based on the off-chain function. Does that make sense?
Yeah, that's helpful. And that might be, so Costa is asking a question. The reason it might need to be linear is if you're doing that off-chain computation and you're trying to prove it back to the chain, it may be easier to do with a linear function. I definitely want to look into this more.
Right. Yeah, for sure. Cool. So economies are dynamic systems, and dynamic systems need liquidity, and token locks weaken liquidity. So we're basically trying to eliminate these, again, thinking like nature. Nature likes smooth curves. You don't find like square waves in nature, where tokens are either totally immobile in a lock or totally liquid when they're not locked. So it's nice to have these kind of like curves and sticking with the fluid dynamics and that kind of system.
So I kind of have a question regarding that as well. Going back to earlier, it was mentioned that this might be useful in a sort of recommendations sort of question. So I guess I'm just going to make up a recommendation scenario, like maybe you're recommending antivirus software. So what happens if like the value of something like very much quickly changes? Like kind of maybe you have this antivirus software and everybody initially, you know, suspects there's nothing wrong with it until like one day news breaks that, you know, the engineers have been secretly instructed to harvest the user's data and like create more malware or something like that. Some crazy like that. In that case, wouldn't kind of votes being kind of volatile actually be appropriate for a situation?
So I definitely hear what you're saying. The rate of decay. So when we're talking about conviction voting at this point, we're not talking about a specific implementation. If the system that you were setting up your recommendation engine, like for, you know, tech, for example, where preferences may change quickly, you can set your forgetfulness factor to you know, a smaller time period. So if you wanted votes to decay in a day or 2 days or a week or a month, you can set that parameter when you are creating your system. And I mean, of course, you'd want to be aware of the effects of setting too short a time period or too long a time period. But that is completely up to the network that implements conviction voting. So if you had something that was a little more fast-paced, you could definitely set your forgetfulness factor appropriately. There may even be other ways to, like, there could be some kind of, you know, breaker switch, kind of like a, you know, something is wrong in the system. And I mean, maybe that's, you know, if the conviction voting is just a recommendation engine, there may be other kind of like emergency measures that users could vote on to, you know, remove someone from a list, or, you know, it depends on the rules of the community that sets up the system. There could definitely be emergency measures in place to protect users against that kind of behavior, for sure. So one other point I had about conviction voting, if that answered your question, was that an okay answer for your question?
Yep.
Okay, cool.
We're wrapping up in about 5 minutes.
Okay. Cool. So maybe I will just summarize from here then, and we can have a couple of questions if anybody has any more. So conviction voting is a continuous preference broadcast over a time set vote. And this can address several attack vectors. Vote buying becomes vote renting, and the cost to do that tends to infinity. We also remove the ability for last minute vote swings due to moving large amounts of tokens from one preference to another. And we also eliminate the potential second order effects from arbitrary token locks. And one of the coolest things about this model, and working with block science in general, they are just about to launch a crypto system modeling and simulation tool, which is an industry first. And we should be seeing announcements about that over the next few weeks. And we are hoping to put together simulations of this system, and then we can plug in all sorts of different parameters and see how the system behaves before we put it into code and get it up on testnet. And of course, these are complex adaptive systems, so it's not a straightforward process, but at least there is an envelope of expected behavior. You can kind of catch those non-intuitive failure modes that we might not think of when we introduce a token lock, but once we see it in simulation, we can kind of figure out more where the system might fail before we start building it, and we can take that into account when we are designing these systems from the get-go. So that's pretty exciting stuff. And with that, we can move into any questions people may have.
Maybe one last question if someone has one.
Cool.
No more questions. That's fine because it's 2:29 and this call ends at 2:30, and I know I have another call very soon. So yeah, thanks everyone for joining. These conversations were awesome. They're kind of lightning conversations because we're trying to fit so much into a small period, but it's still really great. Thanks Ainsley for presenting, and thanks Jeff for presenting. Block Science seems like they're doing a lot of cool research, and they have a lot of PhD academic types that know how to do data and simulations. And I know that that's something that people are looking for more in the space. And I know that Block Science really wants to open source all of their findings. And so I know that you guys are looking for ways to fund that so that you don't need to sell your findings to people privately. So I definitely want to make that known. And so if people, there's a way to do that, if the community can rally around that, that would be awesome.
That's the reason we're focusing on building the token bonding curve model and simulating that before the conviction voting model, because we are hoping to launch a token bonding curve for funding for open science and open crypto research in the coming months. So there will be more announcements about that to come too.
Cool. Well, thanks so much, everyone. I look forward to seeing the progress of anonymous voting and the progress of conviction voting. And I'll see you all hopefully next month. And at Ericon, maybe.
Thanks, Emily. And thanks, everybody. See you next month. Bye.
See you guys.
My